Hello, welcome to Intermediate Algebra, Unit 2, Lesson 4, Word Problems, Part 1. Our lesson objectives are to translate information in a word problem into expressions and equations, and to solve word problems involving one variable. Now, I've highlighted some things here that give people problems with word problems. The big thing is we have to read. In reading, we feel like that's unfair in math class. Well, it isn't. Most of the way we communicate in life is by words. Sometimes now we see videos and things, but you have to be able to read carefully and analyze the text. Then we translate that information into math sentences, which we call equations. You can't just read the problem quickly and pick out the numbers all the time. You have to make notes as you read, and you got to get past the thinking that when the problem's presented in words, you just are to blurt out an answer. Sometimes there are steps to do before you can get there. So that's this. When you try to jump to quick answers because you think you know the answer, like it's a trivia question, you become frustrated and you think you can't do word problems. It's because you're not doing word problems, you're just answering questions. Is a difference. So we get by this with patience, which you'll have to develop, and practice, which I will supply plenty of. So here's the first step. We translate words into math expressions. Now there's some examples here, and those examples, I guess I can't erase this. This is from before. Anyway, the cost of chicken is $2 less than the cost of beef. Well, how do you choose what your variable is? How do you pick what to call X or what to call W or whatever? You choose the quantity that other things are compared to. Here, chicken is referenced to the cost of beef. So let the cost of beef be X. And then if you knew the cost of beef, this is telling you you could figure out chicken by subtracting 2. Less means subtract. So that makes chicken X minus 2. So there are the two expressions you can use in solving the problem. So in the next one, the length is twice the width. Width is represented by W because you're taking length and comparing it to width. Width is what you're referencing to. So let width be the variable. And then you can relate length to width by saying length is 2W. The next one, the cost of a trip to New Hampshire is a quarter the cost of a trip to Florida. This word of means multiply. Of, you see that word of? It means multiply. I'm sorry, I'm still getting used to this stylus. So of means multiply. So the trip to Florida is represented by X because cost of what? Of a trip to Florida. That's what you're referencing to. So a trip to New Hampshire is 1/4 times X. So if you knew a trip to Florida was $400, a trip to New Hampshire would be 1/4 times 400. Your salary is $1,200 more than it was 1 year ago. Now students get confused as to whether X is now or a year ago. Well, your salary now is more than it was 1 year ago. You've referenced this to 1 year ago, so you let 1 year ago be X. And how do you find your salary now? Should it be bigger or smaller? It should be $1,200 more, so you get X plus 1,200. Okay, and then the next one, this comes up in some geometry applications. The length of the pool is 5 more than double the width. Width is represented by W because you got length is found. If you knew the width, you could find the length from this sentence. So, I mean, you could find width if you knew length from the sentence too, but this is comparing length to width. So let the width be W. Then how do you figure out what an expression for the length is? It's 5 more than double. So first you double the width, that's 2W, and then you add 5. Those are some examples that similar to what you may run into as you do word problems. So a lot of word problems deal with geometry in our context. So perimeter, you need to know the difference between perimeter and area. Perimeter is the distance around. If you have a square and you have, a rectangle, length works for a square too though, and width, you would add up length plus width plus this length plus this width, and you would get the perimeter. So it's how much fence you would need to go around that space. For circles, the perimeter is called the circumference. For triangles, it would just be the length of the three sides added together. So it's just the length of the sides all added together. How much fence would you need? Area is more like asking how much carpet would you need. So area of a two-dimensional surface, if we have length and width, the area is multiplying length times width. For a rectangle, that's the most common formula you'll come into, but there are other formulas you may run into, like for a triangle or a right triangle particularly. Let's do is pretend that's a right triangle, and we have a base and a height. 1/2 base times height is the area of a triangle. It's the area of any triangle. For right triangles, the height is easy to find because it's just one of the legs. So those are some typical geometry things you may run into when doing word problems. So let's take a look at what else happens with word problems here. So here's an example. Now this one is not have a physical reality, it's just talking about numbers. When 3 times a number is decreased by 4, the result is 50. Find the number. So you're referencing everything to some number, a number. So I will call that number x. And then 3 times a number, so the number is now x. Decreased means subtract. 3 times means 3x by 4. That's where I get 3x minus 4. Then, so what about 3x minus 4? This word is, let me make this more important here. This word is means equals. Is 50 is equals 50. So now I get 3x minus 4 equals 50. That's an equation to solve, just like in the first couple lessons in this unit. I add 4 to both sides, and that gives me this, and then I get x is 18. So now we need to go back and make sure we answered the question. It said find the number. I said the number is x equals 18. That is the number. So that's an example with just a number problem. And here's another number problem. I put this one in here because of this word exceeds. It means is greater than another by 5. So one number is greater than another by 5. So let the other number exceeds another. So I'm letting the another be x. And my number, one number, is x plus 5. It exceeds the other number by 5. Now it talks about the word sum. Sum means add together. So I have to take one number plus the other number and add them together. And I'm told this is, which gives me my equal sign, 31. So now I combine like terms. I subtract 5 from both sides, and I divide by 2 to get x alone. But then I have to go back and read the question again, because x equals 13 may not be the entire answer or even the answer they wanted. The question actually asks, what are the numbers? They want both numbers. So I found that this is 13. I need to know what x plus 5 is. So the answer is 13, and 13 plus 5 is 18. That's your complete answer. A lot of times students will get to this point here and not go back and read and complete the question. And that's a shame because you've done all the hard part. Example 3, it's a geometry example. Pool has length that is 3 more than twice the width. If the perimeter is 78 feet, what are the dimensions of the pool? Okay, for these problems, I find it helpful to draw a picture. I have a pool with a length and a width. I guess it's implied that it's rectangular. It probably should have said a rectangular pool. But there's a width. There's a length. So I've labeled them L and W for now, but I want to get it down so L is related to W, W is related to L. So which one am I using as a reference? Length is 3 more than twice the width. So length is reference to width. So length is 3 more. You could be thought of as plus 3 or 3 plus, because it's like adding 3 there, twice the width. So what I have is I have 2 sides that are W and 2 sides that are 3 plus 2W. I want perimeter. I'm given perimeter. So I add all these together to get 7, and that equals 78. Then it wants me to find the width and the length. Dimensions means find both. So here's the solution. And you can see I labeled on the diagram of the previous slide. W is the width, length is 2W plus 3. There are 2 lengths and 2 widths. So there's my 2 lengths and 2 widths added together. And that was told that the perimeter is 78, so those added together equals 78. Then I just solve this equation by combining like terms, subtracting 6 from both sides. And then that gives me W equals 12. That's lovely. I know the width is 12, but is that the answer to the question? They ask me for dimensions. That means I need to find the length too. Well, I have to go back to how I set up my problem, and this is why it's important to write these things down. 2W plus 3 is the length. I know the width is 12, so 2 times 12 plus 3 gives me 27 feet. The dimensions are 12 by 27 feet. So here's an area problem. You have a square room. Now a square is a rectangle with all the sides the same. And we usually label that S, but you can call it L or W or X or whatever you want. So you have S there and S there. And the area of this square would be S squared, which is just S times S. So what I know is 144 is S squared, and they want to know basically the length of the side of the square. So, in the solution I used X instead of S. That's fine. So the area is X squared. That's 144. Now to undo an exponent of 2, you take the square root of both sides. And algebraically, you would actually get positive and negative 12, but because this is a geometry problem, because if I square negative 12, I also get 144. So the solutions to this equation are both positive 12 and negative 12, and that's very important to remember. But because of the physical reality of the problem, there's no such thing as a negative length. I just choose the positive value. So the side of the square is 12. So here are some for you to try. I need you to stop the video, and these are in your guided notes, and try these, and then turn the video back on and check the solution. Okay, we'll see you in a few minutes. Alright, here are the solutions. If you had difficulties getting them, you can email me, you can go to the tutoring lab with the problems, you can take them in your guided notes, or you can talk to me if we have a class meeting, or you can get help from a friend, but don't just let it go if you don't understand. And you never know, I might have a mistake. Give me an email and have me check my work. Alright, thanks, and I'll see you in the next video.